Okay, this is a show that. So they're giving this the endpoint, which is that this equation has a root in this interval. So to show there's a root in a particular interval, we need to use the sign change method. And to get started with the sign change method, we need an equation that has naught on one side. So this equation is not ready yet. We need to arrange it into the form of an f of x that equals 0. Okay, so to get 0 on one side, if I choose to get 0 on the right hand side, I can take away x squared and I can add 2. So I'm going to get 3 sine x minus x squared plus 2 equals 0. And I can choose to call this thing that equals 0 f of x. So the first step is to set up an f of x that has to equal 0. Once I've got that, I can now use the two points that I want to show there's a root between. So I look at f of 2 and I look at f of 3, and I can basically get my calculator to work out the values for me. Now I have an equation with a sign in it, so the first thing to check is that the calculator is in radian mode, which it is. Now the most economical way to substitute more than one value into an equation is to, there's more than one way to do it. I'm going to use the X button. I'm going to store my first value, which is 2, and I'm going to store that. So I press the STO button here, store, in the X memory, which is this button X here. Press that. So press equals, 2 is now stored in X. So I can just type out the equation 3 sine x minus x squared plus 2, okay, directly into my calculator. So 3 sine x, calculator wants brackets, minus x squared plus 2. Press equals, and I get the answer 0.7278. So I can round this to 3 significant figures. So I can say f of 2 is 0.728, and then to repeat it with x equals 3, I can just store the value of 3 into memory x, the same way as I did with 2. So 3 is now stored, and replay the calculation that I did earlier, and now it'll tell me the answer to that one, x is 3, which is minus 6.576. And again, I'll go to 3 significant figures. But in fact, all I care about these two values is that they have different signs. So if it's positive here and negative here, then at some point between it should have gone through naught, as long as we're dealing with a continuous function. So do I know this function has got no breaks in it? Well, it's got nothing like an asymptote, and I know that because I know what sine x is like, I know what x squared is like, and obviously 2 is just a constant. None of these functions that I'm adding together have any breaks in them. So therefore, we've got to make the standard statement, which has got to refer to the fact we've had a sign change, it's got to refer to the fact that we've got a continuous function, and it's got to clearly lead to this conclusion. Okay, so this is what we say, f of x changes sign between, we state the x values that it changes sign between, we make the point f of x is a continuous function, and then we reach a conclusion there is a root of the equation in the interval 2 to 3. Now if you haven't met interval notation before, this is just a way of saying these are all values such that 2 is less than or equal to x is less than or equal to 3. In fact, in set notation, that is how you'd write the same set of values as this is describing, except sometimes you see it with curved brackets, and it looks like coordinates. So 2, 3 with curved brackets would actually be the same thing, except on this occasion, if the brackets are curved, it's not allowed to equal 2, and it's not allowed to equal 3. So it's strictly between 2 and 3, not equaling its endpoints. So you may see an interval written either with the square brackets or with the curved ones. It means similar things in both cases. So we are done. The key points of the solution, which I hope are all clear, is I've set up an f of x that has to equal 0. I need to define f of x before I put the values in. I need to point out the sign change, and I need to make this standard statement with all of those points in it.